So first of all, thank you to everybody who's here today. Means a lot to me to be back on campus, and it's really awesome to have everyone here. And along with that, I have to thank Rackspace for setting this up. This came together really recently, and so they asked if I wanted to come here and talk about anything I want to, and that sounded pretty cool. I haven't been back to campus in about 15 years. So real quick on my background. I graduated in 2000 with a CS degree and started to do some .com stuff. And then 2001, I think, I happened to know an artist who got a job at a really small game company called S2 Games. And I kind of just said, hey, do they need a game programmer? I was not one, but I could code mostly. And kind of lucked into my first game job just by virtue of the fact of knowing someone at a small company who they didn't know how to find game programmers either. And once I got there, I was in pretty over my head. I didn't really know a lot about writing performant code or how games work or any of the things that you would hope to know. But it was a really fun job, and I worked really hard and learned a lot, and mostly managed to hide just how much I was ignorant about a lot of things that really mattered. And so after that game came out, which was called Savage, I felt like I had kind of won the lottery because the game, we made it with 7 developers and we created our own publisher. And so after that game came out, we had some success with it. It didn't sell a ton, but it sold a good amount. And people had heard of it, which was a rare thing for someone who's trying to make a game with 6 other people. So my next goal was to go work on a console game at a real, quote unquote, real game company. So I took a job with Namco Home Tech down in San Jose. And worked there for about 6 months, and the place was kind of falling apart. So at the time, we had been playing Call of Duty every night, and I was just blown away with both the single player and the multiplayer. Both of them were awesome, and it really made me feel like not only did they have an amazing team, but that they were doing stuff that was way ahead of what I was, and I really wanted to work there. So June of 2004, I joined Infinity Ward, which was when Call of Duty 2 was just kind of starting to get going. So I shipped Call of Duty 2 in 2005, which was a launch title for the Xbox 360, and it was also on PC. And that was an amazing experience. Launch titles are crazy and fun, and everything's coming together around you as you're building a game. And the game was really successful. Multiplayer was a little bit broken at launch, and that was my fault, but we got that fixed eventually. And then so after that, I did Call of Duty 4, Modern Warfare, and then Modern Warfare 2. In 2010, the 2 studio heads of Infinity Ward started a company called Respawn Entertainment. And so I left and joined there, and we shipped Titanfall a year and a half ago in March of 2014. So that's a little background on me. Let's get started. Oh, and I promised my mom I would tell you that I was in the Marching Virginians for 4 years when I was here.
Play bass drum.
Yes. All right. My clicker's not working. So while we figure it out, I can tell you a little bit about Respawn. As I said, it was started in 2010 by the 2 creators of Call of Duty and about 40 members of the Call of Duty team that left together to go start Respawn. And I was one of those. So it took us really 5 years to make Titanfall. It was a really interesting process for people who had never made a new IP before, because most of the team came in after Call of Duty 1. And even with Call of Duty 1, the rules were pretty set on what happens during World War II, and so you don't have a lot of really tough creative decisions. Sorry, that might be a totally insulting thing. You don't have the sort of blank page problem. You do have a lot of tough creative decisions. There we go. So about 60 developers worked on Titanfall. We're a really lean company. We had about 13 programmers for the entire game. And so now we're up to a lot more than that. And we have a second team headed up by Stig Asmussen, who was the game director on God of War 3. And he's making a non-Titanfall game. It's a third-person action game. That's all we're saying for now. But they're a small team that is going to be growing. And so, yeah, it's fun at Respawn right now because we've got Titanfall under our belt. We're working on a Titanfall sequel, which is what I'm working on. And we have a whole new game team that's going to make something totally new. Hey, it works. So I don't know how many people here are aware of Titanfall. It was, as I said, came out in 2014, but it was announced in 2013 at E3. We won a whole lot of awards. We actually set a record for the largest number of Game Critics Awards that a game has won at E3. We won Game of Show. It was a moment of real pride for me because we had worked so hard and had so many difficulties trying to figure out what the game would be. So having that was awesome. As I said, the game came out. Pretty good reception. It sold really well. And the key thing for this talk is that it is an online-only multiplayer shooter, first-person shooter. Yeah, so we'll do a trailer so anyone who's not familiar can kind of see some about it.
It was only a matter of time.
All of our fight, all of our sacrifice has bought us this one day.
He's ex-IMC. I don't trust him, and neither should you.
War changes a man. It's a hard life keeping the peace on the frontier. Everyone has their limits.
Transferring to pilot.
Okay, so Titanfall is kind of a game about big giant Titan robots and pilots, and the multiplayer is a little bit unique from other games. We have a lot of AI in multiplayer. We have a lot of things happening in the world, so we're going to talk about that a bunch tonight. We're going to cover a few kind of seemingly disparate topics about effects of moving your game servers into the cloud and why you would or why you wouldn't. So I'm going to try to tie it all together at the end, but if it feels a little jumbled, just hang in. So what's important to know for the starting of this talk is that Titanfall uses a client-server architecture. And what that means is there's one game server that's simulating the world and doing all the really interesting things that affect gameplay. And we have a bunch of clients that are talking to that server. And the server is going to give them updates about what's going on in the world. We do ours at 10 times a second. So normally we have 12 players, 36 AI, 12 auto titans, a whole lot of things happening, as I mentioned. A lot of moving entities in the world, and we'll get into what an entity is. And as I mentioned, the thing that's really unique so far in the industry is that we are 100% hosted in the cloud on dedicated servers. So let's go back and let's assume it's 2010. We're starting to brainstorm about what kind of game we're going to make, and we know it's going to have multiplayer. How do we want to do our servers? There's really two ways back then. So most games had servers that were running on a player's machine, whether it's a console or a PC, and one player would be the server for the group. So you'd have 11 players in the case of Titanfall that would connect to that guy. That guy would run the server as well as all the other things we want to have happen on the client so we can play. So at the time, games were limited by the amount of CPU we could get for that server and about the bandwidth that that player would have to provide to the other players who were connected. And there were dedicated servers. A lot of games used them. But for the scale we're talking about, they were way too expensive to be realistic. We would probably make no money on the game. Here's an illustration of player hosted, just so we all get an idea in our head. You have one console in this case that is the game server, and I couldn't fit 11 on here, but in this version we'll say there's 11 other consoles connected to it. And so any player could be a host. There's nothing special about theirs. We just choose one. So dedicated server, all the clients are now talking to an actual machine out on the internet somewhere. So player-hosted servers, the one benefit that everyone used to tout was that they're free. They're not free. They take a ton of extra development time because you need to do a whole lot of work to support it. But they are free in that you're not writing a check every month. And also one big benefit is they roughly scale with your population. So when you have a whole lot of people playing your game, you have a whole lot of people who could be a server. It kind of solves itself as long as you get your numbers right. So I said dedicated servers were cool but too expensive. What's cool about them? We'll get into this bandwidth side, but basically they have infinite bandwidth, and that is huge. You could potentially have a lot more CPU than you would on a home console or a home PC. The networking is really simple. So with player-hosted, one of the problems you have is that your home network is trying really hard to keep people out of your home network. And we need to kind of subvert that and get people to talk to your console or your PC. And so we have to do a whole lot of work to try to punch through that. People who've played a lot of games are probably used to seeing your NAT type as open or moderate or strict. And that's where this comes from. This is only because it was player-hosted. Just like on a web server, you don't have to do anything on your router to get to it. It's open. Everyone can connect to it. So a lot of that work goes away. Also, with player-hosted model, one of those players is going to have a big advantage because everything he does is going to be instantly processed on his own computer. Everyone else has to send their stuff over the internet. And it was a real problem that one player would have a distinct advantage over the other ones, and a lot of people were upset about that. Also, because our server isn't going anywhere, we don't have to handle the case of the server going away, where if it's a player, they can, mom calls them for dinner, they're going to quit out of the game and go eat. And so we suddenly have to, in the middle of a match, find a new server, move everyone over to this new server, and try to keep the game going. It's really hard to do technically, and it's a really bad experience for everyone who's playing a match, as anyone who's had it probably agrees with. So dedicated servers, as I said, they're definitely not free. It comes with its own set of problems, mostly financial. So let's talk about what was actually holding back multiplayer. As I said, bandwidth was a big deal. We're going to go into this a bunch. So this is the 2014 FCC stats on download speeds. So if you look up here, I know this side is kind of hard to see, so I'm going to point to stuff. This is 20 megabit, this is 30 megabit. And so you can see between the range of 10 and 30, there's a whole lot of different ISPs. So this is AT&T. You'll see a big spike here on Verizon because that's fiber. So fiber has tons of bandwidth, and we love that. But there's all sorts of really good numbers. So if people have 10, 20, 30 megabit, how could bandwidth possibly really be a problem? This seems like it couldn't be true. Let's look at the upload speed stats from the same report. So on the upload side, that 2030 we were seeing, that's up here. So there are two fiber again. This one's DSL. That's pretty amazing. But so when we talk about that same bandwidth for uploading things, it's really, you're not even close. Most of these are in the 0 to 5 range, and a lot of these are really much more closer to 0 than they are to 5. So the upload is an entirely different story from download. And that is because people tend to rate their ISP on how fast they can download things. How fast does Facebook load? How quickly does my file download? When I'm watching a movie, how long does it buffer? So that's what they optimize for. And so everyone wants lots of download. Games are kind of a unique thing that we really want lots of upload. And so another thing to keep in mind with this is the US numbers, and there are definitely parts of the world that are not the same as US. There's South America, parts of Europe, and Australia that their numbers are worse than this. So really we're talking about if we were going to figure out what we can depend on getting from a player-hosted server, at most it's really like a megabit, because there's also people at that same house checking their email, browsing, running Netflix, doing all these other things. So we can't just claim all of their bandwidth. We have to make it work with what's available. So as I said, it's great on download, horrible on upload, optimized for the things that people think they care about, and games are kind of get squeezed because of it. So in this case, I would say if 1 megabit is about what they have available, we could probably do 768 kilobit. But that's going to be, you're going to need to find a good host, and the idea that that is always going to be available is kind of also a lie. Just because you test it one time and they have good upload doesn't mean that it will continue to be good. The roommate might start BitTorrenting, and all of a sudden, all that bandwidth is gone. So let's go back and say, could we do Titanfall if it were player-hosted? AKA the question I get a lot of, is it really only possible due to the power of the cloud? So let's dig in. So if we're working with 768 kilobit, I know this is a little bit technical. Don't worry, it's not going to be like this throughout. You're going to have one player who's local, so he doesn't use any bandwidth. He doesn't need to send anything over the internet to himself. But you're going to have 11 more who are out on the internet. So each one is going to get 69 kilobit on average. And then let's explain how we use that. So an entity is what we call anything that moves or changes in a match. So Blisk over there on the left, he's an entity. This Marvin's an entity. The guns they're holding are also entities. Entities have position, orientation, a lot of other simulation things. Players have a lot of state that you have to use of like what they're doing right now. And weapons have the same thing of when could you fire next and all these other things that become very complicated and large. But at a very minimum, most of them are going to have an animation, a model, position, orientation. And so in Titanfall, in the shipping game, it's really common to have at least 240 entities that are changing in a normal chaotic situation. This isn't really worst case. So that's between players and weapons and auto titans, explosions, drop pods, missiles, grenades, all these things that are happening and changing, and we're doing work to tell clients about, hey, the world is not the same as it was a second ago. So if we were doing that on 69 kilobit per player, that would give us about 3.5 bytes per entity to send all of the changes for everything. I know this is really technical, but that includes the bandwidth that you would use to tell it which thing has changed. So in reality, you're down to about 2 bytes to send a position, orientation, animations, and there's just no way you're ever going to hit that. This is orders of magnitude wrong. And you'll have to take my word for it, but we'll get into some more. So if we were on a data center, if we were running on dedicated servers, I think we could safely do 512 kilobit per player in download because, as we showed, people have lots of download. So that would give us over 26 bytes per entity to tell you what's changed, and that is a lot more realistic. So in order to be player hosted, we would actually have to reduce the amount of things in the world that are changing. There's no way to make it work otherwise. And so as a starting point, I would cut those 36 AI. I would cut specters. We have flyers in some maps and drones and drop pods and all these things changing. Those all have to go at a minimum. We probably couldn't do 12 auto titans. And the animation on the players and what's left is going to have to be cheaper. So the end result is that when you're player hosted, you kind of have this you're on a movie stage effect. You're in an empty world. You kind of feel like everything is a facade, and it's a bunch of people running around shooting each other, and around it is kind of empty and lifeless. And that is not a coincidence. So let's go back to this upload speed, or download speed chart. So what if we weren't constrained by these uploads? What if we could get rid of that limitation? As we showed, people have lots of bandwidth, 10, 20, 30 megabit. There's a lot out there that we could use, and we could use it to make a better game and a more interesting game. So because we're using such a small amount of what's available, we are artificially limiting the gameplay that we're going to have in our world because there's less things for you to interact with. There's less things changing around you. And so when you're doing player-hosted, you're really going to trend towards that same sort of a formula of a small number of players in a small area, and they're going to run around and shoot each other, and it can be fun, but you kind of lose a lot of complexity of what kind of interactions you could be doing in that same space. And so my feeling is that these worlds feel non-immersive. You don't feel like it's a real place, and you get artificially simple gameplay. And then if you look at games like Halo, which Halo 5 just came out, they moved to dedicated servers. Suddenly they have a game mode called Warzone, where their player counts are higher, they have AI, they have these mini-boss fights. It's not a coincidence. It's because they now have more bandwidth. So let's talk about server CPU. This is another thing that was holding back multiplayer. So game server work isn't easily parallelized or threaded. So if I take that work, I can't run it on a whole bunch of cores in parallel. And that's because there's a lot of collision work. So if I'm going to move a player around the world, I have to move him and then move someone else. Because if I do it at the same time, they're going to be stuck inside of each other. So that can't be parallelized. And then we have a lot of other collision work. Obviously, players moving, jumping, wall running. But there's also AI. AI have to figure out where they can go, figure out the path to get there, and then execute that path. And they're going to move along it just like a player does. And then we also have a lot of bullet collision that will change an entity. If you get shot, I have to know it. So I can't move you first and then find out that you died a while ago. And so we also have a lot of script logic. And that's where all of our core gameplay is script, really. And so there's game modes and a lot of things that are doing player or weapon logic for players, even some player logic in there. And that stuff is kind of fake threaded, where each thread takes its turn, but they're all dealing with the same variables, so they can't be stomping on each other. So we can't run that in parallel either. And so the Titanfall servers use 2 threads max. One does all the game simulation script logic, and that's where we're doing basically all the work. We have a second thread, and all that does is help write these updates out to clients, but it's not actually changing the world. It's just learning about the new state and trying to get those changes out. And then we also throw some deferred traces on it where it's not going to change anything. I just want to see, what can you see? Can you see over there? And then I'll find out next frame whether you could. So that one's kind of a little one we found, but there's not a lot of wins to do on parallelizing. So because we can't parallelize this server work, that means that faster cores matter more than lots of cores do. And that's really important because when you consider game consoles or even our minimum spec on PC, the Xbox One has a 1.6 gigahertz CPU. It's not an extremely beefy core speed, but they have a lot of cores. And that is going to be a limitation. PS4, for the record, also has a 1.6 gigahertz CPU. They're both around the same. Sorry, Xbox One is 1.75. And so we also need those cores because we're trying to draw the world and do interesting, we're doing culling, we're doing client-side simulation, voice chat, all these things that you actually want to be using the console or the home PC for, is doing something really cool that the player will experience. And so there is a fixed limit because those machines aren't going to get faster. You will be able to optimize your code a little bit, but the machines that I'm running on in a data center, they're going to all be replaced in 3 years. So I'm going to have machines that are faster, and the player-hosted one is not. So there's sort of a interesting, over the length of the console generation, I can actually do more work with no engineering effort. And that really matters. So to follow up on that, if I want to do more, it's a matter of budgeting it. It's not in development time, but in writing a check. I can pay more, get faster cores. I can run less instances per big, beefy machine. And so we've taken a technical problem and made it a cost problem, which is usually always beneficial. So let's talk about, hopefully you understand we can't have done Titanfall on player-hosted, so that's why we did dedicated. But why would you do it on the cloud? Why not just do dedicated servers? So one of the things you'll experience if you work in games is that when you ask how many copies are going to sell on launch day or how many players will be there on launch day, nobody has any idea. The marketing guys will really excitedly come to you 1 week before launch and say, great news, we think the game's going to sell double what we thought last week. And this is terrible news. Because if I'm going to rent servers, usually it's a lead time of months. Usually like 3 to 4 months minimum. Depends on how much you want to pay. You can get it done sooner, but it'll kill you. And so because even if their estimates are changing, they're still wrong. Because a lot of people don't even pre-order a game until a few days before launch. There's nothing the marketing guys could do to really nail it. They're all just trying to read signs and try to figure out an estimate. So the only safe thing to do is to take their estimate and go above it. And it is kind of magic to figure out how much to go above it, because there's downsides to either direction, right? So let's look at the Titanfall launch. This is what any game launch looks like. I've launched a few games now. They all look like this. And so on launch day, you go from 0 users to a really, really big number. And then your first weekend is big. Sometimes it's bigger than your launch, depending on what day of the week it is. And then over the course of that month, it's going to be a steady drawdown with weekend spikes. And that is, every game you're ever going to see that's like a AAA launch is going to have a curve that looks like this. So how do we make sure there's servers for everyone? So here's the trick, is if I'm going to rent servers and run them, I have to handle the peak. And so I'm going to pay for all of that block. I really want to pay for the green part. I want to pay for the part that players are using. I don't want to pay for this red part, and that's the majority of it. I don't want to pay a bunch of ISPs all over the world to have servers sitting there doing nothing. So because we're using the cloud, we're coming closer to paying for the green part. It lets us not pay for servers that are sitting idle. Another way to put it is I'm going to let someone else foot the bill for those. The cloud companies can sit on those servers and sell them to someone else. I don't care. I just don't want to be on the hook for it. And that is really important. If you look at the magnitude of that last chart of just how much money is saving us by not paying for that red part of the graph. So let's talk a little bit about Titanfall's dedicated servers. So our dedicated server is just a Windows 64-bit app. We have 3 different builds, and they differ only in the data. The executables are all identical. And so we have 3 builds. One's called a party server, one's called a training server, and one's called a game server. They have different levels because they do different things. Party server does that little lobby screen that you're probably used to seeing in the game if you played it. It's very small, 310 megs for the whole build. Training server has our training level in it, so that one's about 600 megs. And then the game server has all the levels, which I think is 25, 26. So that one's about 8 gigabytes. So this is the main screen of the game. This is the only screen you're going to be on where you're not on a server. Everything else in the game, you're always on one server. So this is the party server. This is when you go hit play, it's going to put you on this machine. Party server has a shared core. It's doing very little work, so we don't need many resources for it. 750 megs of RAM, and this is an Azure A0 for those who are curious. And so this screen, the server, is really doing a small amount of work for letting you change your persistence, doing some authentication, and we'll get into what else it does on the matchmaking side. So let's say you go into training. Now you're on a training server, which is a single core machine. There's only one player. There's a pretty small number of AI. It doesn't have a huge need for CPU. The RAM's fine because the level's not enormous. And so you do your training, you finish, and then you're going to go play your first match. So you hit a full game server. This one uses 2 cores, like I mentioned in the earlier slide. This is an Azure A2. It's got 3.5 gigs of RAM. And this has all the, the enormous number of things changing in the world. We're doing all these really expensive game updates to 12 players at once. And so this is our beefiest server. That's the most we need. So let's talk about the back end. Respawn's back end is something we created and we call Strider. And it's called Strider because it's really lightweight and fast. It handles authentication, matchmaking, game monitoring, and skill. So for authentication, basically it's just saying, does this player own the game? For matchmaking, we're going to go into that next, but it's going to find you a game to join, basically. For the monitoring, it's going to collect statistics on the health of our game servers, the health of game clients, and also some statistics that help us tune the game. And then we have our own skill system that runs on Strider, and that's going to help find a match that's interesting to you. And finally, we'll get match results. And so we can use those match results to adjust your skill and also to collect some information about what's happening in our world and how patches change things, and we can use that again for tuning. So on the matchmaking, let's get into how matchmaking actually works with cloud servers. So the goal of matchmaking is to find 12 players across the world, divide them into 2 teams, and have them play matches together. And so the real trick is trying to collect all these players who would like to play and figure out how to chop them up and get them an experience that's going to be good. And so getting them all onto the same server is the eventual goal. So real quick, I'm going to talk about matchmaking because I've been through a whole lot of matchmaking fights in my life. Every single one has been a variation of this argument of there's really 3 things that people are going to fight about. Do you want really good skill match? Do you want the game to be full? And do you want really short latency, low latency servers? And you'll never get all 3. Unless you have just the most enormous population that it's a self-solved problem. But if your population isn't the world's biggest, there's going to be people on either edge of that skill curve who you can either play with people who aren't your skill, or you can sit with 4 people in a server and the game's not full. And you have to compromise on all 3. And that's just the nature of it. Every fight I've ever had has been someone who's sure that there's an easy answer to one of these. You give up on blank, and the problem is gone, and it's never gone. You have to compromise on all 3. The trick is to do it as little as possible. So let's talk about matchmaking. So in most games out there, the clients will search for a server to join. When they can find one to join, they'll go connect. But our problem was clients are the least reliable node in our whole net graph. Clients do horrible things because it's home internet. So someone's going to reboot a router, and you get disconnects and timeouts, and they get packet loss, especially on Wi-Fi. And then one of the different problems is that not every platform that we work on has a really good HTTP library that I can rely on without getting sort of random errors. And so on Windows, and our dedicated servers run on Windows, we use libcurl, which I've used for years, and we've spent 2 years trying to find all the issues with it and get it ironed out so it's totally reliable. And so because our dedicated server is the most reliable both build and node in our graph, I want to do the matchmaking on the server. So Titanfall does that. So the general process is you're going to talk to Strider, you being the server, talk to Strider over and over and saying, here are the parameters of what I need to find. I need an attrition game with, I have 3 players in a party, and here's my skill and all these things. And it's going to come back and say, I got nothing for you, I got nothing for you. And you're going to send how long you've been searching in total. So it'll say, I've been looking for 20 seconds now. And given that you've been searching for 20 seconds, we're going to get a little more desperate and try to find, this is where the compromise comes in. We're going to find you something because I don't want you to search forever. But giving you a little bit of time gives us more of a shot of finding a game that would be a good match, too. Time is saving us as well as being the frustrating bit. And so we use that time in a really predictable way. If you've been searching this long, we're going to expand it this way. If you've been searching this long, we expand it that way. And we can also track it on the back end, and that's some of the monitoring we do. When we're looking at problems with the game, we can pull up a graph showing how long people have been searching. And when that starts to go up, alarms go off. So let's rewind. So assuming there is no server to join, you're the first person to ever play Titanfall, and you hit play. We can search as many times as we want. There's no game out there for you to join. So what we do is after a certain amount of time, we're going to go tell you to go sit on this empty server over here and wait for other players who are searching to find you. And so that's what we'll do. And so you're kind of an anchor. And so you're going to go, given that there's nothing there, you're going to go sit, and then other players will join in, and eventually your game fills up, and you can go play a match. So there's the 2 parts. There's the searching, and then you give up on searching and go be a thing that other people will find. So this is sort of an odd thing, but it's worth talking about. So when you've dealt with a shipping game, you have to figure out what to do during downtrends, and they're really normal. We'll show that next. So what we do is we have servers always searching for other servers. So this isn't on behalf of players. This is a machine that is trying to find another machine to take its player base and put them together. And one of those servers now goes away. It's done. And so during the lobby countdown between matches, that's what we're trying to do, is that server's out there looking for another server. If your game's not full, maybe we can get a full match by finding another not full server and combining them. So why would we do that? That's weird. So, well, this graph's hard to see. But so this is later during launch month. This is a Friday, Saturday, Sunday, Thursday, Friday, Saturday, Sunday, and Monday. And so every weekend you're seeing a big bump like that. But you can see during certain times of every day, you're going to have this area where there are more people leaving your game than joining it. And that's something you have to deal with. So incoming players cannot fill the gaps. There are more people quitting than joining. So every game out there is going to be full. It's going to go 6v6 to 5v6 to 4v5 to 3v4. And if you're playing that, it's going to feel really awful. You might be someone who just likes to play really late at night in your area, and so most people are going to bed, and you're just starting to get to play. So we have to try to figure out how to make that work where you don't feel like the game is this steady process of everyone forcing you to give up too. And so that's what these server merging is trying to do. As these servers empty out, we're going to find another one that's also emptying out, merge them together so you get a full match. So during these drops, the game doesn't feel like it's being abandoned, and that's really key. So let's talk about parties. So parties are, for anyone who's not familiar, parties are a system where you can get together with some friends. You're going to matchmake as a unit, and you'll always be on the same team. It's a really popular system. It's been around for a little while. So it's a really common case that we really care about is the case where you have friends who love this game, and they tell you, you need to pick it up. You got to come play with us. And so that new player is going to party up with them because he likes his friends and he wants to talk to them while they play. And so we really care about that. We want it to work. So, but the problem is parties break a lot in a lot of games. People here are probably familiar, if you've ever tried to do it, that not everyone makes it into a match. Maybe half the people don't, or maybe one guy gets dropped, and then you go, where'd Jimmy go? All right, let's back out, let's re-party up, and let's matchmake again. It's really frustrating. And it's a horrible first experience for that guy who's never played the game before. It's a horrible experience for everyone, but especially for someone who's trying to figure out what this game is. So why do they break? The main reason is it's a race condition. So when we do our search, we say, I need a game that has room for 5 people, because I have a party of 5. And we say, great, here's the server. And you tell your friends, hey guys, let's go over to this new machine over here. And in that process, someone joins. And so now there's only 4 spots, and 1 or more people don't make it in, and then they're stuck. The party breaks, and now some of it's in the game and some of it's not. And so I wanted to fix that. We wanted to fix that. And so parties should always work. They should always be reliable. No more of this thing where you have to back out and try again. So what we did is we created a system that we call reservations. So when you're matchmaking, the one will talk to the game server and say, I've got 5 people, or in this case 4. I need those spots reserved. Don't let anyone else connect and take any of those spots. If someone comes in, tell them the game's full. And so that server was trying to say, got it, you're reserved. Here's a password for everyone to use, and they can get in on these reserved spots. And so the party server, who's doing your matchmaking for you, as we discussed, then has organized this. The players are totally uninvolved with this process. All the players say is, I want to matchmake. And the server goes off, does all the work for it, comes back and says, you're all set to go. Here's a new IP and port, and here's a password to use when you get there. Go have fun. And because the server's out on the internet, there's no NAT traversal. We don't have to get through anyone's home network. It's going to work. There's just a public server sitting out there. And so we made parties reliable. And one of the things that is important to note about this, there's a few kind of development lessons here. Parties don't get tested a lot in development because that's not how developers play. Usually you announce that a play test is starting, everyone bangs on play, and you go play a match. But nobody's actually trying to party up and try to do all this stuff. So it's a rarely tested case. So what I did is I made it so everyone who's playing is testing the party code. So you're always in a party, even if it's a party of one person. There is no party code path and a non-party code path. It's all unified. And this is one of my lessons that maybe I can pass on, is that especially in network coding, rare code paths are going to be the ones that break. You have to try to eviscerate any rare code path and make it just use the same code every time. And specifically, make your hard case be your average case. At least if it's only in development, that's OK. If you can make it all the time, that's even better. Because in networking, your worst case is what really matters. What's the maximum amount of bandwidth I need? What's the worst case for drawing players on the screen? And so this is a tangent, but let me go into it. So there's a lot of older games that did PVS, potentially viewable set. And so they try to do this thing where I'm going to only send you the changes of things you can see. And what I found is it sounds like a really great optimization. And then without fail, there'd be one map that designers would make in every game I've ever shipped where they would do a big open map. And so what you can see is everything. And so that optimization was really just hiding our worst case, and it made it harder for us to find and fix it. And so that really was hurting us, not helping us. And so it took extra CPU, it took development time, and it was hiding problems that would hit once the game came out, or after the game came out. And so you really have to try to figure out how to find your worst case and test it and test it and test it and fix any problems that hit. Don't try to do optimizations that make it harder to find that worst case. So let's talk about how do we actually bring this all together. We know we have cloud servers, we know we have matchmaking, but how does it really work? So because we're running in the cloud, we can't use DNS. We're going to have a constantly changing mix of servers. They're going to spin up and spin down. Their addresses are going to be different every time. Day to day, it's going to be a completely different set of servers. So I can't have anything in the game that tries to just figure out where to go, because it's going to change. So Strider handles this. So Strider talks to all of the dedicated servers out there, and it can figure out which ones are running right now, which ones are gone, and try to, as we showed in the earlier matchmaking slide, all the clients do is go to Strider and say, where do I go? And it says, here's an IP port, go connect there. And so that's how we manage the kind of DNS replacement part on Strider. So there are 2 big cases. We've kind of talked about it roughly, but there's, I need a brand new server. I'm going to go do training. Give me an empty training server just for me. Or in the case where matchmaking takes too long and we can't find a game, we're going to say, I need a brand new game server. It should be empty, pristine, so I can go in there and wait for other people to join. And then the other case is the matchmaking one, where I'm going to search over and over for running games. It definitely should not be an empty server. I want to find a match to join. So we use something called Xbox Live Compute on Titanfall. And it's a layer that runs on top of Microsoft's Azure, which is their cloud. And you can see in the game we have 4 data centers in the US, 2 in Europe, 3 in Asia, 1 in Australia, and 1 in Brazil. And you can see in the game, you can pull up the data center list and see your ping to each one. You can see it's real. And so Xbox Live Compute, that layer, what does it do that Azure doesn't? It deploys builds across data centers. So when we upload a new game server, they'll go ahead and distribute it out to all of those data centers and get it primed and ready to go. They can patch builds in place for kind of bug fixing. And then the most important of all is they're going to look at the predicted need. They're going to look at the time it takes to spin a server up and where we are now and try to figure out how many servers are going to need whenever whenever these spin-ups happen. So depending on how long it takes to get your server, the more far ahead it has to guess. And it's a really critical and really scary problem. And so what it actually does is it spins up a whole server. It copies our game package into it. It unzips the game and even runs the executable before we ever ask for a server. And so our executable will run. It does a call into their library, and that's going to block. And so it's now halted, but it's running in whatever sense you want to take that. And so they call this standby. So everything's been initialized, but there's nothing happening. It's just sitting with at a gate. And so what we do is Strider does or anyone does a call to an endpoint at Xbox and pass in the right credentials and say, I want a machine. And Xbox Live Compute will then talk to that thing and unblock the executable, which is what they call allocating it. But in reality, the allocation happened a long time ago. And so the executable now unblocks and it starts running and it talks to Strider and says, hey, I'm here, I'm empty. Nobody's using me. And so we can now hand that out to players who need an empty server. So our first attempt, this is back in December of 2013, 4 months before the game came out. So we had the allocations were a multi-step web call thing. So we'd do one call, it would give us a handle. We'd do another call with that handle and get results. It was kind of a long pipeline of calls we had to do to actually get the server. And best case, allocations took 4 to 7 seconds. This is back in December 2013. It's changed since then, but this is what we were dealing with. And that wasn't fast enough for us. Excuse me. So the classic case that we hit was, you're in a game lobby, we're counting down to the next match. You can see this counter that's ticking down 10, 9, 8, 7. And someone's working on their loadouts and changing the equipment on their character. And they go, wait, I'm not ready to start. I want to back out. And they'll do it usually around 1 second. And so if it takes 7 seconds, they're in a new match. And then we tried doing a thing where we halt the countdown while we wait for a server to allocate, and then everyone else in that lobby is sitting there looking at a thing that says 1, 1, 1, 1, and it's not going anywhere. So both were really frustrating for either the person backing out or the game who was just trying to play. So what we did in January of 2014, 2 months before launch, we moved to a totally new model where Strider is going to do all the allocations. The game will never allocate anything. And so we're going to have a fixed size pool of empty servers that can be per region, per game mode, all these things. And so there's going to be these empty servers that are sitting in Strider. We have a list of them. And then when someone says they need a machine, they talk to Strider and say, give me a list of empty servers. And so once they connect to that server quickly talks to Strider and says, I'm not empty anymore. Take me out of the empty list. So that's going to go, and then that kicks off a job that says, hey, our fixed size pool of servers we need more. We're out. We're not at capacity yet. So go do an allocation, which will take 7 seconds-ish, and then it'll fill that pool back up. And so the size of that pool gives us a lot of room in figuring out, basically we want to have, worst case, we want to have a pool that's 7 seconds of servers worth so that we never run out and it'll refill itself as players need it. But it also gave us a lot of possibility of making that much larger. So during launch, if things started to look a little choppy on the cloud side, if they were having trouble allocating servers as fast as we needed, we could take that pool and make it really big. And we could choose the amount of time worth of servers we've already allocated and are waiting. And so we can kind of weather some not really outages, but some problems where they can't match the rate that we need. So we can kind of catch up when it can get back again. And more importantly, when we do all the allocations on Strider, it gave us this incredible insight into the health of the system. We can now see everything that failed. We can see error codes. We can reproduce it. We can try to debug things. And we have this window of time before it's ever going to hit a user, because we know we have a certain amount of servers that are ready to go. And so we can spin up a tech support ticket before an outage has happened. And that turned out to be really, really awesome and really useful. And it hid a lot of problems from users. So let's talk a little bit more about Strider. That late change thing we did with 2 months until launch, really, was really key. It saved our butts. And it was because we already had that backend service. If we hadn't, we couldn't have written Strider from scratch at that point. It was because we were already using it for matchmaking that this was a really simple change to do. And this empty server thing was a whole new idea. Nobody doing matchmaking supported this use case. It wasn't a thing that providers offered. And so it was only because we were really nimble that we could go add this new idea in and do it in a couple weeks and have it working. And so Strider saved our butts. So let's talk about the downsides of the cloud and dedicated servers. So it obviously saved us a lot of money over renting servers, but it was still a really expensive option. So basically, I would say it makes it affordable, but it's not cheap. You're still going to spend a whole lot of money on servers that your competitors might not, but you should be doing it because you're going to offer an experience that's impossible without it, and players will notice that. And also, costs are dropping quickly. If you look at these cloud companies, they're all racing each other to try to be the most affordable, and you really want to piggyback on that. So Titanfall is probably the most we'll ever pay for dedicated server hosting, even though our next game hopefully sells more. And the game after that should be even cheaper. So we're going to ride a curve down of cost savings and faster cores. And so I'm basically piggybacking off what IBM and Amazon and all these big companies are going to spend a huge amount of capital doing, is trying to figure out how to run servers more efficiently. It's not my fight, it's theirs, and I'm just going to benefit from it. So the other thing is about cloud is that player-hosted is more resilient than cloud hosting. You can kind of think of it as a big distributed graph of nodes, and one can't take down the others. There's no single point of failure, with the exception of matchmaking and persistence, which are kind of singular points of failure in general. No matter what you do for your hosting, it is solvable, but it's hard. And so we found that the cloud servers, the services can get into a bad state. We can't allocate servers. It impacts players. And it happened more often than I would like to see. And as an industry, we have to try to figure this out, because outages should not be a thing that gamers have to deal with. They shouldn't have to understand the details of a network topology or the ramifications of the way we chose to host. The game should just work all the time. But that said, this is a hard problem. This is not something I can go fix in a year. This is something that will take time. We need to figure out how to make everything more resilient, more distributed, and less points of failure. So now that we've gotten through all the hosting and how dedicated servers work, we're just talking about a really important consideration that comes with running your own servers, and that is patching your game. So you have to plan on patching your game. Any online game is going to have balance issues and bugs and exploit. No matter how much testing you do, you're not going to find them all at the scale of millions of players. There will always be something that your QA team can't find, no matter how big you make it. Unless, I guess you could do a few million QA, but it's probably not realistic. So you have to plan on having them. You're going to have problems you need to fix. You have to have a plan for how you will fix it. It's not an if. And for all these things, speed is really critical. When that first word gets out about your exploit, people are going to actively try to use it, and it's going to hurt your game. If it happens on launch day, it's really bad. They could completely destroy the reputation of your game, especially if it's a new IP. If people say, it's this weird game where someone just stomps on everyone, and I don't know why, but they had constant Titan, I never got one. It can really damage your years of hard work and your ability to actually keep functioning as a company if you can't make your money because people abandon your game. So let's talk about how we patch our servers. So basically, we do all the development to actually do a code change. Let's say it's a bug fix in this case. We figure out the bug, we do the code change, we check it in, we test it internally, we're happy. Then it goes to the QA for sign-off. So they're going to do a whole lot of internal testing for anything that's going to go live. And then they sign off, and that's the starting point here. So QA is now signed off, the work is done. So we upload that build into Xbox Live Compute. It's going to distribute it to all of our data centers. Strider is going to start allocating that build instead of the earlier one, because each build has a unique name. And then players are going to hit that new build. The minimum time for rolling out a change like this is about 2 hours, we found, and most of that's on the uploading and distributing the build. So that's for servers. Now we got to talk about client changes. Here's the thing, on pretty much every platform now, there's a step called certification, where you're going to upload your build to whoever owns that particular platform, be it Origin or Xbox or even Sony or any of these things. So you're going to upload a build. That platform owner is going to test it and make sure that there's no problems, and they have a whole team that does this, and that team needs time to really bang on it and make sure that it's solid. And they control the update system. You can't opt out of this. And yet games still crash and have bugs, as we all know. So let's talk more about certification. This is where John gets to come and talk about whatever he wants, is really going. Okay, so for a client patch, let's talk about how we roll it out. So it's the same step. All the development work happens. We get our change checked in. In-house QA does their sign-off. They say, we've tested this. It's ready to go. At this point, since it's a client change, there's also a corresponding server change, so we kind of have two builds to get out there. The server one goes exactly like we mentioned on the server slide. So the client one, we're going to go, we've now signed off internally, and our QA team is incredible. And so they take that seriously. If we get a sign off, it's something that's solid. So then it's going to go to our publisher. It's going to go to EA. EA is going to have their internal QA team. They don't have as much awareness of the details of what we changed, so they're going to kind of bang on it a bunch with a lot of bodies, but they don't exactly know what the bugs might be. So it's kind of a less valuable QA step. When they're done, they're going to submit it to the platform holder. Let's say in this case, Xbox. So Xbox is going to do their certification pass, and that one takes a while. So the minimum time from sign-off, not from development, but from sign-off of we think this is ready to ship to getting it to an end user is 7 to 14 days, and really it's more like 14. The 7 is very rare. So let's talk about that path of 14 days to get a change out until anyone can use it. Going through that much QA is expensive, not in terms of writing a check, but in terms of hours worked and manpower. The QA teams have other work to do. So if you submit to certification and another game is trying to ship, you're going to get pushed aside for that game. Maybe it's even fair. It's just something you need to realize. And so more importantly, if it takes 14 days to get a change out into the wild, if your game breaks, if you ever screw this up and something really bad goes out there, it's going to be 2 weeks before you can fix it. And so the real danger here isn't that they will miss it. It's that when they miss it, your game could be in real trouble. And so the danger is in doing a patch. If you leave it alone and it's okay, you're fine. If you try to fix it and you're wrong, there's real danger there. So let's talk about how long should certification take. The Big Book of Slothy says certification should take as long as you want the game to be broken when it's broken someday. So to show the server versus client, we ship dozens of server patches, sometimes more than one a day. We had this 2-hour turnaround, so we could push something out to investigate a problem and then push out a fix for that problem later on in the day. We could fix things really rapidly. And it carried very little risk because as long as we did our thorough in-house testing, if there's a bug, it would be rare. And if it's a rare bug, we can quickly fix it. So there's very little fear factor in doing these updates. So this is one of my favorite things. I went and found one of the Titanfall exploit videos on YouTube. And because of gamers' expectations that game patches are rare, you have someone replying to the uploader saying, you need to take this off YouTube. You can't tell people about this bug in the game because it's going to be destroyed. The game is going to be worse. And the guy said, I would rather get attention so they could fix it. Also, it was fixed the next day. And so that's only possible because we ran our own servers. If we had been done player hosted, that would have been a video that gets a ton of views and is broken for 14 days and is really bad for our player base. So let's talk about a summary here. We've covered a whole bunch of things. Let me bring it all together. So consumer broadband is upload constrained, and because of it, it will change your game design. Data centers are the way around that, so you can do new things that haven't been done before. Your bandwidth is going to dictate your game design. It's not vice versa. You're not going to figure out the right game you want to make and then figure out how much bandwidth it's going to use, or it'll never come out. So also, you can't estimate your servers correctly. Your sales estimates are going to be wrong. Don't trust them. It'll kill you. And in the case of us, using the cloud right saved us a whole lot of money from renting bare metal servers. As I said, Strider was really important. I really recommend it. If you're just going to do web queries and have your own parsing in the game, it's not a huge investment. Web stuff scales really well now, provided you use the right infrastructure. Make sure you load test, but web scaling is really a solved problem. So don't assume that there's magic there just because someone else is doing it. Yes, there are matchmaking and other services provided by other companies, but it's not a hard problem. In fact, scale with matchmaking is really small because there's very few people who are looking for a match. Most people are in matches. If you have a whole lot of people looking for a match, it means that the matchmaking is broken, not that it doesn't scale. And finally, my little pet peeve about certification. They want to kill your game. And I mean that. They want to try to find every problem before it ships, and that is an unrealistic goal. It is a false goal, and it means that if you ever screw up, you could really destroy your franchise, or at least your game. So I want to do a whole lot of Q&A, but we can take a quick break for if anyone needs bathroom break or anything. So I'll leave this up as I'm here to answer any questions you guys have. My only request is I'm doing another talk tomorrow night about netcode. And so if you have like a netcode or networking a game question, save it for tomorrow night because I'm going to do that there. But for any of the topics we've talked about or any sort of general game development, this would be a great venue for me to answer. I'm ready to honestly answer any question you guys have that I can answer. So the question was about the architecture of Strider and whether we use it to sort of prime before big weekends hit or sort of things to help manage cost. So Strider is really simple. Like I said, it was Nginx with PHP talking to a Redis database. And basically we have a number of web front ends. We have our Redis or a few Redis databases. Matchmaking has its own and a few others have their own. Those web front ends can answer any type of query, and so they'll talk to the right database for each query type and send the answer back. And so if we want to scale, the thing about Redis is it's an in-memory database. It's incredibly fast. And so there's almost no way we could hit the limits on Redis with the loads that we have in a video game. And so basically any scaling problem we have can usually be fixed by just adding another front end. But Nginx is such an efficient front end that we probably could have shipped with a single web server doing it. We had more than that because people are always worried, including me. So the actual architecture of Strider is really simple. Web front ends talking to multiple databases. In theory, we could have also had read slaves of those Redis databases, but we built it for that and then didn't need it because Redis is just that fast. And as far as what do we use Strider for in terms of the scaling? Since Xbox Live Compute is handling that prediction, all they're doing is looking at the rate of servers we're asking for and trying to match it with prediction ahead. So we don't actually need to do any work. And in fact, if we, like on those tops of those curves, we maintain the pool even at the very top. And so we could optimize that by shrinking the size of our pool on the way down because it save a small amount of money. But my worry is more that the game works rather than trying to squeeze every penny out of it.
So the hoster takes care of that for you?
Xbox Live Compute, their layer on Azure, does the scaling part. So we do pay for the servers that are sitting empty, but the pools aren't huge normally, and we can shrink them per region. So in places where there's not a whole lot of people playing, we can have a really small pool of servers. In places where there are a lot of people, we can have a bigger pool. So it should kind of scale with population. So the question was, do you get to pick your own data center? And yeah, on our main menu, we have the what data center you're on right now with a button you can hit or click it, and it'll give you a list of all the data centers with your ping to each one, your latency. And so you can pick which one you want as your main data center, and then we'll matchmake using that. So in the case of power users, the one case where it's really legit is if you have two clans, really competitive teams. One's West Coast US, one's East Coast US. They can pick one of our two Midwest data centers so that no team has an advantage, and they can have a really even playing field. Not a lot of people do that, but it was something we thought might be useful, and I have heard anecdotes about teams doing it.
Thank you.
So how do we make sure that the requests that Strider is handling come from our own game servers? So some of it is because people have no idea what the query should be, and so we get a little bit of secrecy there because we never shipped our server. It would be trivial to attach a certificate to it. It just hasn't been worth it because it's not really a problem we've encountered. But since we can patch our servers, I could do a 2-hour turnaround to fix it if anyone found a way to do it. For some of the other queries, there are certificates attached. Like when we allocate servers, only Strider has that certificate, and it can send it. So only Strider can do those allocations. Even if they get our game binary, they can't do it. So there is a kind of a stop valve on the stuff that would actually cost us money. So have we had to update Strider? Yeah, we do a lot of tweaks.
Downtime on that?
No, so the way it works is the engineer who handles all the Strider stuff, he's got scripts so we can kind of deploy script changes out. So we'll have a staging web server that we can test in development, and then when we want to push that change live, it goes out to all the web front ends and hits people immediately. So in none of our updating process do we have any planned downtime. So when we have a new build come out, we can spin those servers up while the old ones are running and spin the old ones down when they're not needed anymore. And so the entire process was designed so that we would never have an outage while you're playing. That's intentional, at least. So for the question was, how long does it take to spin up a new build over an old one? So again, that one is per region or per data center. So we don't do the thing where we start allocating only the new build, because basically you would cause a huge stall while it tries to spin up these servers, and that takes minutes. So we start kind of doing a mix of, we're going to hand out the ones that are there, and we're going to start spinning up. And when we have enough, the old ones will start to shut down because we're not going to send players to them. And so I didn't get into this in the talk, but our deallocation strategy is really simple. When a server sits there unused for 15 minutes, it shuts down. It just exits. So that way we can kind of ride the curve down, and in the sense that spinning up a new build is the same thing as the daily curve you already see. Players are not playing anymore, and so those servers will go away.
So is that like order of magnitude, like a day or like 12 hours?
The question of how long does it take to finish? Usually there's not a huge amount of servers running, and so we can replace them within a few hours. Worst case is we have some servers that, like the party server, where people will kind of bounce through it and keep going. And the 15 minutes timeout might be too long for that one, but so those ones can kind of keep going for a little bit longer. And then the other case is if people just keep playing on the same game server and they don't ever leave, that will also prevent it from shutting down. So we have had some cases where there's a server that's like 24 hours old, but by a few hours in, the majority of them are the new build. So the question was about rollbacks. Yeah. Thankfully, we never had to do a rollback. Yeah, if we were, it would be like a new patch. We would take an older build, upload it with our thing, and start allocating again. Or if it's literally identical, we could just start allocating it again. But we never had a moment where we had a no shit and had to go back. Thankfully. So the question was, how do we, for game entities, you mean, what's the architecture?
Well, yeah, what kind of architecture do you use? Do you just use like the standard, inheritance, or do you use a, entity component system?
Okay, so we started with the Portal 2 engine, and Valve's code was very object-oriented and inheritance-based, so you'd have really deep hierarchies. And we've been trying to collapse that down. Ideally, I think, well, it doesn't really matter because we're not close to it, but I would prefer a component system over the sort of deep hierarchies. But we have to live mostly with what we've got, and we can try to make it better and better over time, but there's no moment where we can just go do a huge change. We kind of have to live with their architecture to some degree. So the question is about cross-platform gaming. It would technically be possible to have people on multiple platforms play on the same server, but there's two really hard problems. One is that on PC, there is always some amount of cheating, and we have anti-cheat technology to detect it and ban those players. But if we were to turn that on, basically we would be allowing cheaters into the console world. And I find that as a real loss. But the other problem is patching. So because there's different certification on the different platforms, I can't coordinate when these patches roll out. So I can't do a coordinated rollout on both PC and Xbox of a new game version that's going to hit at the same time, and I can keep everyone together. So during those times, people are going to have to be on different servers. And because that's really hard to do, we keep everything distinct for those two problems. Questions about load. For Titanfall, the Xbox One was our biggest platform by a good margin. We did really, really well on Xbox. Question is about how do we coordinate our releases. And so I'll talk about Xbox because it's the more interesting one. Normally they like to do their updates in the middle of the night when no one's playing. And my problem with that is that since we need to have our server spun up at the same time as the client patch hits, I want to do it when there's people in the office, both at my office and at Microsoft, and thankfully we're in the same time zone. So we always did our patches either 9 or 10 a.m., I can't remember. And so I would be sitting at my desk, the patch would start rolling out, I could verify that it was rolling out, I could get it on my console, make sure it works. So if there's a problem, because patching is so terrifying, we can learn as soon as possible and start trying to ring alarms, but it's still really bad. But I don't want to be caught off guard by waking up and finding out the game has been broken for hours, or that there was some problem with spinning up these servers, and again, the game's been broken for hours, and we have to try to start at a broken state. So for that reason, we did ours during kind of, not quite prime time, but during time where you would actually see players playing. And that has its own downside, but yeah, I think it was worth the risk. Yes, so the question is, do we get to decide the rollout time? And Yes, Microsoft is pretty easy to work with, and Origin is run by EA, so that we can dictate to them a lot easier. But yeah, Microsoft guys, they prefer to do it in the middle of the night, but when we told them our concerns, there was no fight. So we worked with them really closely on Titanfall, and it was a very good relationship. So the question was about, after Titanfall shipped, we had the entire company basically work for about 9 months on doing updates. And we sold new maps, but everything else was a free update. And we added really big changes to the game, like a co-op mode and new game modes, and we did a lot of changes. We added black market. We added just really huge amounts of changes to the game. And basically that was a two-part thing. One was it was a big commitment to our player base because we really wanted the game to succeed and we wanted to reward our fans who came with us on the ride. And the other one was we kind of decided as a company we wanted to get some expertise in the sort of games as a service, not in the business model sense, but in the sense of we need to learn to update our game. This is a core part of multiplayer games now. We don't really have a lot of experience in doing it, and there is all this fear and all these things that we have to get over. And so it was kind of a decision of let's just agree we're going to patch the game regularly. We have to get over the fear barrier. We have to do updates. We have to learn to get good at this. Because it's something that is expected from a lot of gamers, and it's important to us that we fix any problems and add cool things to the game to make sure it stays vibrant and as a thank you to our players. And the question was, is that worth it? Which is a much more difficult question to answer. We definitely could have used those 9 months of developer time to work on something new. Generally speaking, the first year of development of a game, even on a sequel, is kind of, we call it wasted time, but it's not really wasted. It's your time to try all sorts of really different things. Almost none of them are a home run. And so the feeling at the end of it is we've accomplished nothing. And so there is some good argument that you can have people doing updates that players care about while other people brainstorm on what would be an interesting way to go on a new game. But we also kind of postponed our learning process too, because we still had some of that when we started working on a sequel. And so I think the answer is somewhere in the middle. I think definitely doing all those updates was a really good learning experience, and I'm really proud of the game as it is right now. But if we had ended it a little sooner, we probably would be a little bit farther ahead, but it is what it is, and we're doing fine. So I think it kind of comes out in the wash. So the question is, how do we do ops? Live ops on a running game that's using cloud servers. As I said, we're really lean. So basically, myself and another engineer, and the other engineer did almost 100% of the live ops, which was a terrible thing that we couldn't really figure out a better solution for. Most of our problems were with third-party outages. And so basically, what he actually endured was he would set up monitoring and alarms. Those alarms would go off saying, this is looking unhealthy, we're not keeping up with our allocations. And then he would spin up a support request with Xbox or ByteVault or all the different components that can fail. And then he would kind of have to sit and wait for those other teams to fix it. So the live ops were frustrating in that we didn't have control over it. And it wasn't something that I could just go fix on Strider, because we love those problems. We're good at that. But it's really hard when we're doing monitoring for someone else's product, because the best case we can do is just tell them there's a problem. And so this is something we're working on, because it's obviously not scalable to have Mike, who's awesome, do all of our online live ops. And so we're going to fix that. And over time, all the services have become a lot more reliable, and the scale is a little bit lower. So it's kind of temporarily corrected itself, but as soon as we ship a new game, it'll be all right back in our face again. So we really need to fix it for a future game. So the question is, what do we do 5 years down the road when there's still people playing, we're still paying for servers? Do we want to get out of that business and have someone else pay to run those servers, or is this just a cost going on? My feeling is that the really nice thing about player base 5 years later is it's passionate, but it's small. And so the actual cost of running those servers is pretty small. And the cost of shutting them down or basically throwing them into a lurch is pretty high. People get really mad, they don't want to buy your games again. But that curve just keeps kind of getting smaller and smaller, and it drops off slower and slower over time. So we're not plummeting, but it's going to keep shrinking over years. And so my personal preference is go ahead and write the check, keep the servers running. We don't need a whole lot of servers, so the check's going to be pretty small. It's worth it to make sure people know that they can trust us to buy our future games and that we care about them. Question is, how much are we actually paying for these servers? Unfortunately, that's one that I'm pretty sure I can't answer. But when you look at a game launch of the size of Titanfall or any sort of AAA game, it's not going to be the most expensive thing on your budget, which is a pretty big deal. And so that's probably the best I can get. And then keep in mind on that launch graph, I would say most of your costs are going to be launch month, maybe even most during launch week, if you can ride that curve down. So if you get it wrong, you're going to be in trouble. And so it's really key that you start getting started on spinning servers down and saving that money, because if you wait too long, and we did wait a little too long in some of our training servers, you'll waste money. And so, for my opinion, it's not our job to come up with a completely efficient system. It's our job to do the best we can, learn from it. Next game launch will get better. Game after that will get even better. Because after Titanfall launch, we learned a ton. And we learned all sorts of ways that we could run things more efficiently and save money. And we found problems that were wasting CPU on the server and fixed them. And so that was after the curve had already kind of crested, we'd missed the majority of the savings that would have come from those fixes. But it means that next time we'll get them. And so you kind of have to avoid that risk of beating yourself up over missing things. Because it's not our goal to make a perfect game. No game I've ever made is perfect. And that's not my goal. And so you just have to accept we learned a lot. Next game is going to be even better. And we got off on a great footing on Titanfall. We made a game that I'm really proud of. If the costs were higher than it could have been, that's OK. We'll fix it next time. And we'll fix it next time again. So the question is, how many people are on each team at Respawn? And so I said we were about 60 developers when we shipped Titanfall. That doesn't include QA. So I think by the time Titanfall shipped, we had about 85, 80, somewhere in that realm, people in the entire company, 60 developers. And so since then we've grown. We're about up to 125 employees right now. Our second team, led by Stig, they are pretty small still. I think they're 15 to 20. And they'll grow bigger as their project comes more online and they figure out more of exactly what it'll be. And so there's going to be a growth there. But the actual core development team of Titanfall, pretty much we've hired some more people. And so it's a little bigger than it was. And we're all working on the sequel to Titanfall. And Stig's team is growing on its own. So far, there hasn't been a lot of mixing people around. But that might be in the future. I don't really know.
Can you tell me the percentage wise how many are females?
So of the company, let me figure out. Not a lot, sadly. And
on one hand, probably, right?
yeah, definitely I could count them on one hand. I really hope we get more women working in game development. It would be big. But that also applies to all sorts of groups that are underrepresented. More voices in the industry would be a big benefit to not just them, but also to our games, our company, and our customers, because we really need those voices in development. The question was about our monitoring system. We use StatsD. And StatsD is a pretty interesting and simple little process that per stat, we can track the granularity of how much it stores. So we're going to report what the current value is, and it'll do sums, and it can do kind of interesting math there. But then you kind of have this eternal database. So for some of the stats, we do every 10 seconds. And then over time, once it becomes, we can set this, but like say a month old, it'll compact that to an average of every 10 minutes. And then a year out, it'll do every month. So you can kind of pick at what granularity you want to store it. And all that does is save you on your storage space. And the idea is that data is less interesting when it's old. But so StatsD, we can do it on a per stat basis. So some things we really care about, we really don't want to degrade it much. Other ones, even when we first report it, we don't want a 10-second interval because it just isn't very useful and we're wasting storage. Question is, as one of the biggest customers of Xbox Live Compute, did we get to give feedback to them and change the design of the system or give them ideas of where we'd like to see it go? And the answer is yeah, absolutely. So Titanfall had an alpha and a beta. Our alpha was a closed alpha. It was pretty small. And unfortunately, it didn't catch a lot. And so then we did our Titanfall beta, which we really tried to find the limits of basically, they had written a whole bunch of new code, we had written a whole bunch of new code, you're going to have bugs. So the goal of the beta was to find all those so we don't have to find them on launch day. And so we had a really constructive process with Microsoft where the goal of the beta was to break everything. Let's find all these hard limits, or maybe not hard, find all these problems with the system and debug them live, get it fixed, prove that it works. And so our beta was really wildly successful, even though it was an extremely painful process. We had an 8-hour outage on our first day of our beta, and that was really hard. I was sitting in a war room at Microsoft with some people there, laptops were watching graphs, and we could walk down the hall to the Xbox Live Compute team, talk about what we're seeing, talk with them about how to fix it. So on a very emergency level, we definitely got involved in the process of fixing it. But even on the bigger level, we gave them a lot of feedback on here's what we care about. There's some features they supported that we just didn't want to use, and so we said that's cool, but it's not useful to us. And also we talked to them a lot about how to manage those graphs and the scaling and all these things. How do we try to figure out how to make it a little more cost efficient without changing the way it works? And so yeah, we've worked really closely with them, and it was a really fun process. I spent about almost a month between beta launch and the 360 launch up at Microsoft, sitting in a conference room talking to people at Microsoft. The question was, what's the health of the game industry as a jobs market? And yeah, that's something that I've been really lucky in that definitely when I joined, it grew like crazy. And then there was a lot of contractions, game studios closed, and then the social game stuff took off for a little while, and that seems to have peaked a little bit, and now we're into mobile gaming and all that. So basically when you look at revenue, it's a home run. It's growing like crazy. But it's also full of dramatic change. So it's not necessarily like a guaranteed safe industry. You have to stay relevant. And so just in the change that's happened in since Respawn was formed in 2010 has been really scary to watch, but exciting scary because it's all about people growing and finding new ways to do things. But it also means that you can't just sit back and assume that the way you've been doing it is the right way. So there's a little bit of chaos, but as far as growth, the game industry it's growing a ton, and it's growing a ton by expanding into new directions. Cell phone gaming wasn't a thing 10 years ago, or not a significant thing, and now it's huge. Mobile games or social games and all these other free-to-play has been huge. And so it's growing, but kind of by cannibalizing the old safe way of doing things to some degree. And so I've been lucky enough that I'm still doing AAA console games and PC games as well. And so I haven't really had to change a whole lot other than the stuff we talked about here where I wanted to fundamentally change how we host games. And so that was sort of a behind-the-scenes change that impacted players, but it wasn't a business model change. So what did I experience going from .com web stuff into game dev? So it was definitely a huge change, and I was pretty underqualified for doing game dev work when I started. But yeah, I mean, that's probably to be expected for a junior person. But I really had to learn fast. And so the thing with web development is that you don't really learn about writing performant code. You can try to find architectures that run fast on a web server and interesting ways of caching and kind of problems that are very web specific, but it's not going to help you when you have to go write a game engine. But at the same time, all the stuff I learned doing web stuff, when you look at Strider, that's what happens when you have an ex-web developer do game development, is suddenly I want a database, I want web front ends, I want to move our calls to be RESTful web calls, I don't want to do a custom protocol. And so it's really been beneficial to have that knowledge. And as we keep doing social and mobile games and websites that integrate, it's really important and it's really useful, maybe not important, but it's really useful to have that knowledge of, oh, I could build a website that can talk to our game. I can have a website where people can go to and see stats from our game. All these things that have been useful in development and maybe something we're going to improve on in the future, but it's turned out to be really useful. So I would recommend that people get some knowledge about doing web stuff, but at the same time, it's not going to help you when you're writing C++ code in a game engine. So what makes a game successful?
Wouldn't we all like to know that?
Yeah, it's a hard problem. I mean, my personal criteria for any game I make is I want users to love it. That's number one. Everything else is secondary to that. Sales obviously matter because I want to keep making games, and we have to turn a profit or the company will go under because that's how money works. And then third is I really want to push the genre along. I don't want to do a game that doesn't push any limits. I want to move the industry forward if I can, because how many games am I going to make in my lifetime? I want to be able to look back at them and say I'm really proud of that one we moved things forward for the industry, which is a really tough thing to do. I'm not saying that that's easy, but that's what drives me. So the question is, how would I fix CERT without just saying that Respawn doesn't need it and everyone else does? And that's a fair question. And so my preference would be, as a starting point, you cert your game to go gold or to go to manufacturing where they're going to put it on discs. I'm okay with that because it can catch important things. Once you know that your game already does the right thing, all these updates become a lot safer. The chance that I'm going to do a patch where I'm going to suddenly start calling a system call a lot more often it's not really realistic to what we do in a patch. And so I'd rather see it move to a model where you do your updates. If there's a problem, it's a Sev 1 thing. They come to you and say, you need to patch this right away. This is broken, and it's up to you to go fix it. But you can't do it before the patch goes out or you get these problems. Basically, it's the problem of what would happen if when you're writing code, you could only run it once every 2 weeks. It's kind of the same issue of like, I'm going to do this stuff that might only hit in production. How do I debug it? And if it takes 2 weeks to run it and find an issue and go fix it, all that happens is everyone gets really defensive and you try to pack in all the stuff you can possibly do just in case. I don't know if this function can fail, it shouldn't, but what should I do if it does? And now you have code paths that you don't even know how they can run that might be getting hit in production. And that is also really bad for users, as you mentioned. So I understand it's a really tough problem, but if you look at services like Steam that don't have certification, there is no lower game quality there. In fact, those games usually work really well. And so if you just use your model of let's look at the effects of it, it's hard to argue that CERT is actually improving game quality. And obviously I feel it's detracting from it, but even if you were to flip that over and say, like, is it doing any good? It's really hard to identify any particular way that it's helped. But obviously you're right that the certification teams have a really legit argument that they're there to find big problems before it hits users. And they always have horror stories of games that submit and have big problems. Most of those are during the going gold, not on patches. And so yeah, I can definitely see that. And I understand that not every company is going to get it right. But I think we move to a part where people understand that if a game is broken, it's not Microsoft's fault. They can go yell at the developer, and as the game industry is huge. We're talking about franchises that are worth billions. So the idea that EA or Activision or any of these other ones are going to be careless when shipping updates is kind of, it's living in a world that's not realistic, because how much is Call of Duty worth to Activision? How much are they really going to risk on pushing an untested patch out? And if they do, why would anyone get mad at Microsoft? That is an Activision problem, and they should fix it ASAP. And so that applies to every publisher. The industry is so big now that we have a lot more at stake than Microsoft does. And when you take that into account, it's obvious that we're going to take this seriously. Now, if there's a really small developer that maybe has less at stake than Microsoft, I could see that. I don't really know how to do it fairly, though. Like you mentioned, of maybe you have to have a tier thing of once you've done enough games or enough patches that you get into a secondary tier. And if you're new at development, you might have to have some handcuffs on you. I don't like that solution, but maybe that's the more realistic one. But I think if you're going to try to do a solution that might make the big games worse in order to support small games, it's maybe not as pro-consumer as you think. And that's the part where I take exception. Do we use deployment freezes? Oh yeah, so when we're going to ship anything, let's say we're going to do an E3 demo or going to try to submit the game to certification. Basically, we will lock the tree. No one can check in without permission. At some point you do Sev 1 bugs only, so I don't care if that thing really bothers you. I don't care if you don't like the balance on that gun. Pencils down. We're only going to fix the things that are catastrophic errors. And we'll do weeks of that, worst case, of nobody's allowed to be doing other work. You're testing the game. We're fixing the issues that come up. And then when we're through that, we will take that build and move it to a different tree and then unlock the main tree again. And so we take it really seriously when we're doing one of these builds. And we do that for everything that we're going to show publicly or have hands-on or things like that. It's a really big deal. And it takes a lot of development time that's quote-unquote lost, but not really lost, to focus on getting all the big problems out of your product so you can ship. So what about rolling those deployments out? Yeah, early on into Titanfall's update, I made a rule of we will never patch on a Friday, because if you get it wrong, the ramifications are too big and people won't be at the office at some of our partners. Even if we're willing to come in and work on the weekend, I can't dictate to Xbox that they need to be there on the weekend. So Thursday would be the latest we'll patch, and even then it better be important or really, really safe. And so basically you want to do your patches early in the week when your player counts are a little lower, like you saw in the graph earlier. And so it'll give us enough time that if there is a problem, we can fix it before the weekend hits, as long as this is a server patch, like we talked about earlier. So did Valve's Source Engine help us move into the cloud? Yeah, it'd be hard to say it didn't, because they did have pretty robust dedicated server support. All their games run on player-hosted or data center dedicated servers, not run by them, but run by the community. And so we kind of started from a good standpoint of they had a great client-server architecture, at least in the separation. And then the dedicated server was known and tested. We obviously made a ton of changes on this game. We really did massive changes to that engine. But we started from a good point, and we had a good kind of a setup of these dedicated servers work, and we can use those and run them on the cloud. So I didn't have to invent that part, or we didn't have to invent that part. And so, yeah, it did help, but not in a direct sense. They didn't have anything there that was like set up for cloud or set up for this kind of thing. We wrote a lot of new code. Obviously, we wrote our whole matchmaking system. And so kind of moving into the cloud was all new to us. But the existing dedicated server and client architecture was already there, and that was a good starting point. How do you know when a game's done? Basically, you have a ship date if you're doing it the way we've always done it. So you know when your game's going to launch. You work backwards from there. You need so many weeks for manufacturing, and then you need so many attempts to pass certification. So you need to build in a buffer there, where each certification run can take a week or two, as we said. So you need to, by the time you've worked back, you're a significant number of months away from launch that your game actually needs to be done and submitted to Xbox or Sony or whoever you're submitting to. And so that becomes the first step is we know the game needs to be done to this date. We need to build in time to make sure it's done by that date. And so you kind of hit a point where it's pencils down of you're done, time's up, you know it needs to be done, so you better have made it shippable at that point. And so there's an earlier point where it's no new features. For us, alpha is basically feature complete or content complete, but it's not necessarily bug free. It's not as polished as we want it. So once we do that, I don't care if you have a cool idea. Write it down when we're talking about next game. Bring it up. That's the time. And then so from then on, let's get this thing shipped. Let's find every issue that is really critical or a real problem of the appeal of the game. Let's fix all those and get it done and get it out the door. What I've learned is that when you keep trying to work on a game, if you keep saying, I need more time, the process of learning is really not happening. You're afraid of releasing it. And really after a game comes out is when you can look back at it and have a really honest, and it's important to learn how to do this, but you can have an honest reckoning with what works, what doesn't work, what should we build off of, what should we get rid of. You have to be brutally honest if you're going to make a good following product. You have to be able to admit all the flaws, and it's okay. It's okay. As I said, none of my games are perfect. They never will be. But you have to go in knowing that and say, all right, what part do I like? What part do I not like? And also for our customers as well. So when do we determine the ship date? That one is driven by a publisher working with the leadership. And so we try to figure out what's the right amount of budget and time we want to spend on a game, and then you work backwards from there. And some of that comes into like when do you want to launch it? Because time of year that you launch a game can be really critical. And so basically in November you have a crunch of all these really big heavy hitters that all want to fight each other to the death. And you have to be really careful about targeting that because you can get squished, or you could be that heavy hitter that squishes everyone else. So it's kind of a winner takes all. In October a little less so, but you're still kind of in that same mix. And so we launched Titanfall in March because it was a brand new IP, and so we didn't want to get squished. And so that one was a mixture of here's how much time it takes to build a company from scratch, come up with an idea for a game, execute on that idea, and get it shippable. And some of it was to do with the timing of the Xbox One. So it came out in the November before, and so we couldn't have shipped before then, or it would have been a delayed release of PC and Xbox. So there's kind of a bunch of market forces and discussions that happen to figure out your release date. And we hold that's one of the things about Respawn is, and back at Infinity Ward it was true too, that your release date doesn't change. We don't do we need more time, it holds. What do I think of VR? My honest opinion is that you can do some really cool immersive things with VR. For sort of a thing where you want to feel like you're actually in a place, you can do really powerful stuff that's really cool. I definitely get nausea from it after a little while, and the newer ones are better, but it's still not something that I would come home from work every night and put on for 4 hours. And it also doesn't necessarily match the experience I want to have when I get home, in that if you're tired, you sit on the couch, my dogs are around, I might have a beer if it's that kind of a night. And first of all, drinking a beer with VR goggles on is not a thing that you want to be doing. Second of all, like swinging your body around or moving around when you can't see your environment is really not a good thing. And not everyone's going to have a big empty room that they can turn into their VR room. So I think it has some issues, but the experience is great. And so I'm kind of curious to see how it does. My expectation is that it's going to be a little too hardcore for any sort of a really casual audience. But I think there's a lot of money to be made for people who really want a hardcore gaming experience that's really immersive. So I think there'll be a lot of companies that launch software and do really well. I'm not sure yet how big that market will be. My honest answer is I'm more excited about augmented reality in terms of hitting mass market, because I think that's a lot less scary to put on something that lets you still continue to see around you than it is to put something that blocks your view. True or false, have I played Titanfall with Oculus? One of the engineers at work, Ramy, who's a really gifted engineer, the company shut down for 2 weeks last fall as kind of a thank you for everybody working so hard, go have some time off, don't come into work, it's closed. And he spent his 2 weeks getting Rift support in our engine. And our main lesson was that our game is a terrible mix for VR. We have really, really high move speeds. You're going through the world at 50, 60 miles an hour, I think. And it's really not a good experience. It's terrifying, and it makes your stomach churn. When you eject from a Titan and go up in the air, it's all bad. And so I think that for a good VR experience, you really have to start with doing a VR game and trying to figure out what works in VR, what doesn't work in VR. You can't just kind of add it into existing game. But I'm glad he did it. It was really fun to play around with. I don't know if that's a direction we'll ever go or not. So what are the highs and lows of starting a business? We learned on Respawn that it's really, really, really hard to create a new IP, especially with a team that's been doing sequels together for a while. And I include myself in the problem of, like, we have this urge to just go create, and that's not how you make a new IP. You have to kind of have moments of reflection and brainstorming, and you're not typing things into a computer. We had whole days at work at the beginning of Respawn where we just sat in chairs in a circle. We didn't even have a computer. And we would talk about, what's your favorite game? Why? What's your most disappointing game ever? Why? And we'd go around in a circle and just talk about all these things. What did you like about this game? And some of them were, like 80s games that people had played. I really loved this old Commodore game because it had this cool thing. And you have to go through all this brainstorming. And even when you go through it, it's really hard. The problem with there's the blank sheet phenomenon. If you have no limitations on what is possible, everyone just sits paralyzed. As soon as you start having limitations, everyone's creativity comes out. And so the biggest problem you have is if you tell a room full of designers, hey, come up with some game pitches, everyone goes, what is my area that I'm limited to? And it's like, whatever you want, racing, RPG, third-person action, first-person shooter, whatever you want to do. They go, I don't know. And even if you brainstorm, you just get a whole bunch of people talking about things they like, aspects they like, gameplay ideas, kind of concepts that are fun. Like, I liked this game because I could stealth. That was cool. And they're all really good to know, but trying to have the ability to tie that together into here's a game idea I have. Maybe you have this giant Titan robot, you're going to fight other Titans, you're going to jump out as a pilot and run around. The process of getting there is really messy, and it's really hard on the team. And I think that's just part of it. It's fun and it's hard, but you have some real lows. In any project, there's at least one point where you feel like everything you've done is terrible, it's all been a waste of time, and you might be a failure as well. And you just have to know that's coming and get through it. And it's really hard. It's those moments where the team can start to fight each other and sort of general unhappiness is setting because everyone's frustrated. And when people are frustrated, that comes out in really ugly ways. And so that's just part of the development process. Every game I've ever worked on had that moment. Call of Duty 4 had a moment that was so low, we just looked at what we made and it was like, this is awful. We're trying to do this modern shooter, all we know is World War II, it just doesn't work. And Titanfall was even more so because we had no rules at all. There was no this is realistic, this is a list of guns that exist in the world. It was create everything, create a universe, create a story, create characters. And it's just hard to do, but it's fun because at the end you're so proud of what you've done. And I think that kind of applies to all of game development, but especially we found making new IP is just really tough. So what do I think about Unreal Engine and other engines that are semi-free or free? Yeah, writing an engine's really hard, and as they get bigger and bigger and bigger, kind of the word engine means less and less to me. So, like, there's a lot of things that have all these crazy plugins and all this stuff, and that's not really an engine. That's a whole ecosystem of tools around an engine, and there's some really great tools that you can do on some of these not public domain, but sort of free and widely used engines. And you get some benefit of kind of the scale that these engines have. But at the same time, you also pay the price because everything they do has to be very general. They're going to have a whole bunch of different games that use that functionality, so they can't scope it like we can. So when we do everything in-house, we say, what's the feature we need to do? What's the best way to do that thing in terms of time and efficiency for the CPU efficiency, GPU efficiency, and the time to develop? And so we can come up with things that aren't really flexible, but they do exactly what we need, and they're really fast, or they use low memory. You know, like, we can get better solutions because we're not supporting an external team. And I find personally for development that works a lot better for me. I can get more work done, and I can know the right way to solve a problem because I'm not solving a general problem, I'm solving a very specific one. The question is, how do I feel about reverse engineering in order to keep playing old games and sort of all the different funny aspects of that? So, as I mentioned earlier, I really don't want any of my games to be unplayable until the point where there's so few people who want to play it that it can't work because there's just no bodies there. But I definitely think if we ever abandon a game, which I really don't want to ever do, I would love to do it in a way that we release something out to the community so they can keep playing, because there's no reason not to at that point. If it's not worth anything to you, give it away. And so my opinion is keep it running, do it right. If it ever came to the point where there's so few people playing that it wasn't worth the effort to keep cloud servers going, I would definitely want to release something for the community. The question is whether what we have right now would be useful to the community. And so as long as it requires Strider to do all that matchmaking, we might have to do more work. And that's going to come out in some way, like whether I'm pulled off the current game we're making to go spend time on it or someone else is. But there's kind of sort of a trade-off of the product we're currently making would have to suffer at least a little bit in order to do that. Hopefully my goal is that we never have to do that, but that's my personal opinion. This isn't an official Respawn answer. So yeah, what about open sourcing your game when you're quote-unquote abandoning it? So one of the problems, ramifications of this, is that we license the source engine. So one of the things we can't do is license their engine and then open source it and release it to the world, because that's a revenue stream for them. And so I think there's legal issues with it, but if it weren't for that, I think it's cool to open source stuff. I think id showed that you can do it and there's no real loss of business. There's really nobody out there who's using Quake 3 to save money on Unreal, especially now that Unreal's free, but even before then. So I think, generally speaking, you're going to have teams that want to write their own engine and teams that want to use someone else's. And as long as the teams that want to write their own, sure, they could start with your open source thing, but you can do it in certain ways that'll prevent them from closed sourcing it and making revenue off of it. If you want to, or you can just open source it. And then the teams that want to license something, they don't want an old engine. And so I think it's not really a problem, except for all the legal parts that make it hard. So would I work on a different genre than first-person shooter if I had the choice? What I've learned is that my influence on a team is pretty small. And I think everyone's influence on their team is pretty small. Because the reason I've made games that I'm really proud of is because of the team of people working together. So if I wanted to go break off and make a different game, it would probably be a really disappointing game, and I would probably regret leaving. You kind of have to accept that. And not to say that I don't have an impact, just that I'm not a secret key person. I'm just a person who knows how to work well with a group of people, and we can make some really great stuff when we work together. And if I were to take myself out of that, it wouldn't necessarily be true anymore that I can make something great. So this is not to say I don't love first-person shooters. They're the majority of games that I play. So I think in my case it works out well in that the games I make are also games I really like. But I think even if I were to work on a different first-person shooter with a different team, I might have a totally different outcome. And that's just something that I've learned as working this long. Finding the right team is a lot more important than basically working on the thing that you think will make you happy. Because it's about the product, and it's all hard work. So there is no job you're going to do where everything you do all day long is awesome and fun. The thing you're trying to do will be awesome and fun, and it's going to take a lot of hard work to get there. And so finding a team that can make that fun, doing hard work with a whole bunch of other people that you have fun doing hard work with, that's a lot more important. If anyone else wants to come up and chat afterwards, I'll be up here for at least a few minutes. I raided our swag cabinet at work, so I have some burn cards and patches to give out. So anyone who wants some of those, please come up, say hi. I would love to meet all of you. And honestly, thanks again for coming out, and thank you, Rackspace, for putting this together. I really, really appreciate this crowd. This has been fun.